Good morning, friends. Today we will discuss unit number second, steam condenser. So this is revision of second unit. In this unit, we have discussed what is condenser, function of condenser, advantages, types of condenser, like that. So, what is condenser? It is a closed vessel used to condense the steam. The low pressure steam give up its heat to coolant, heat water from cooling tower and get converted into water during the process of condensation. Condensate extraction pump. It is a pump which is installed in between the condenser and hot well. It transfers to condensate from the condenser to hot well. It is a sump that rises in between the condenser and boiler. It receives the condensate from the condenser by condensate pump. The feed water is transferred from the hot well to the boiler. Boiler feed pump. It is a pump installed in between the hot well and boiler. It pumps the feed water from the hot well to the boiler, and this is done by increasing the pressure of condensate above boiler pressure. Air extraction pump. It is a pump used to extract or remove the air from the steam condenser. Cooling tower. It is a tower which contains the cold water, and this water is made to circulate within the condenser for cooling of steam. Cooling water pump. It is a pump rise in between the cooling tower and condenser. It circulates the cooling water through the condenser. Working. The steam condenser receives the exhaust steam from one end and come in contact with the cooling water circulate within it from the cooling tower. As the low pressure steam come in contact with the cooling water, it condensate is condensed and converted into water. It is connected to the air extraction pump and condensate extraction pump. After condensation of steam, the condensate is pumped to the hot well with the help of condensate extraction pump. The air extraction pump extracts the air from the condenser and create the vacuum inside it. The vacuum created helps in their circulation of cooling water and flow of condensate downward. Classification of steam condenser. The steam condenser is classified as jet condenser or mixing type condenser, surface condenser or non-mixing type condenser. Now, what is jet condenser? Jet condenser is a condenser in which condensate get mixed with the cooling water. That's why it is also called mixing type condenser. This type of condenser is used sometimes because it lost some of the condensate and require high power for pump during the process of condensation. Injet condenser. As the condensate is not free from the salt, so it cannot be used as a feed water for the boiler. It can be used at the place where sufficient amount of good quality water is available. Here, low level condenser, parallel flow jet condenser, counter flow jet condenser. Parallel flow means water flow and steam flow parallelly, and counter flow means water and steam flow opposite direction. Barometric high level condenser figure shows. Barometric and high level jet condenser are provided at a high level with long vertical discharge tube or tailpipe. It does not have condensate extraction pump and condensate of cooling water flow in hot well because of the gravity. An injector pump is used to flow cooling water at top of the condenser. These types of jet condenser are used at high level with vertical discharge pipe. In this condenser, the steam enters at bottom and flow in upward direction and meet with the downcoming cooling water. Its working is similar as the low level jet condenser. In this condenser, steam enters at bottom and flow in upward direction and meets with downcoming cooling water. Its working is similar as the low level jet condenser. The vacuum is created at top of for the condenser shell. With the help of vacuum and injector pump, the cooling water is moved to top of the condenser. The condensate and cooling water come down the hot well through the long vertical discharge pipe. And finally, the extra hot water flow cooling tank and cooling pond at overflow pipe. Injection condenser. Figure shows injector condenser. In injector condenser, it has non-return valve through which exhaust stream enters, hollow truncated cones and diverging cone. In this condenser, the cooling water is injected at top. The steam enter into the condenser through non-return valve. The steam and water mix with each other while passing through series of hollow truncated metal cones and steam change into water. At the end of the meter, cone diverging cone is present. When the condensate passes through the diverging cone, its kinetic energy is partly transferred into pressure energy. The condensate and cooling water is then discharged to the hot well. This is surface condenser. Surface condenser is a type of steam condenser in which the steam and cooling water do not mix with each other, and because of this the whole condensate can be used as a boiler feed water. It is also called non-mixing type condenser. Types of surface condenser: down flow and center flow. Figure shows down flow condenser and center flow condenser. Surface condenser. Down flow surface condenser, the steam enter at the top of the condenser and flow downward over the tube due to the gravity and air extraction pump. The condensate get collected at the bottom and then pumped with the help of condensate extraction pump. The pipe of dry air extraction pump is provided near the bottom and it covered by vapor plate so as prevent the entry to the condensate into it. The steam in downflow condenser flow perpendicular to the direction of flow of cooling water, so it is called as cross surface condenser. Center flow surface condenser. In central flow condenser, the steam enter at top of the condenser and flow in downward direction. In this suction pipe of the air, extraction pump is provided in the center of the tube next as shown in the figure. Due to this placement of the suction pipe in the center of the tube next, the exhaust steam flow radially inward over the tube toward the suction pipe. The condensate is collected at bottom of the condenser and pumped to the hot well. We can say that it is improved from the downflow surface condenser. Regenerative, evaporative. In regenerative surface condenser, the condensate is heated by the use of regenerative method. In that, condensate is passed through the exhaust steam coming out from the turbine. This rises its temperature and it is used as feed water for the boiler. In an evaporative surface condenser, the steam enters at the top of the condenser in series pipe over which film of cold water is falling. At the same time, current of air is made up to circulate over the film water. As the air circulates over the water film, the evaporates some of the cooling water. As a result of this rapid evaporation, the steam circulating inside this series of pipe gets condensed. Remaining cooling water that's left is collected at increased temperature and reused. It is brought to original temperature by adding required quantity of cold water. Advantage of steam condenser: increase the efficiency of the plant, reduce the back pressure of the steam, reduce the temperature of exhaust steam, allow the condenser to feed water. The temperature condensate is more than the feed water. What is air pump? Air pump is a machine which is used in the condenser to remove condensate air from the condenser. Basically, air pump create vacuum in the condenser as nearly as possible corresponding to exhaust steam temperature. It is used in the condenser to remove both air and condensate from the condenser. This is two type. Edwards air pump. These two types of air pump available in market: dry air pump and wet air pump. In the Edward air pump chamber, when the reciprocating piston is at the top position, the condensate of the air from condenser enter into the pump in the conical portion of the lower part of the barrel through the ports. It is short at low portion of the pump chamber and this is position cover the ports. Now the piston start to fall down from upward position and a vacuum is created top of the piston due to head valve is closed by the water. Now ports are open. Again piston move to add downward. Mixture of condensate, vacuum and air enters at the top of the piston. This mixture is compressed and pressure will be slightly above the atmospheric pressure. When piston start to move in upward direction at this position, the river valve is open, which allow the mixture to pass on the top of the cover. The relief valve is pressed in the base of cylinder to release the pressure. Steam jet air injector. What is injector? Injector is device used to suck gas and vapor from the desired vessel or system. As injector is similar to the vacuum pump or compressor. The major difference between the injector and vacuum pump or compressor is had to moving parts. Hence, it is relatively low cost and easy to operate and maintenance free equipment. Principle of injector. The operating principle of injector is pressure energy is moving motive fluid is converted to velocity energy by an adiabatic expansion in the converting diverging nozzle due to pressure drop of the motive fluid. It is will create low pressure zone before the mixing chamber. Due to the low pressure zone, the suction fluid will start to move toward it and mix with motive fluid of the mixing chamber. In mix fluid enter the diverging portion of the injector where its velocity energy convert into pressure energy. Benefit. Injector can be operated with the many different motive fluids, steam, air, organic vapor and other gases. No motive parts, no lubrication, no vibration. Hence low maintenance cost when to compare with other peer equipment. Injector can be installed indoor, outdoor without restriction. Can be installed at any orientation. In space requirement will be very low. Initial cost is very less, no spare required. Easy to handle, corrosive and slugging liquid. Cooling system. Open cycle, closed cycle, circulating water system in thermal power plant. All thermal plant by the coal-fired nuclear use the modified Rankine steam cycle. The steam existing from the steam turbine condensed in a condenser and then reuse the steam cycle. Almost all thermal power plant use surface condenser for cooling the steam. The only exception is in geothermal plant where the direct contact condenser is used. Open cooling system. In open circulating water, the water from large water body like the sea or river or lake pump to condenser and return back to the same source. Since the sea is free and large open source of water, we see many power plant located on the sea coast. Advantage. Large quantity water is freely available. The water temperature is almost constant. Disadvantages. Organic and aquatic growth can plug condenser tube reducing the efficiency. It requires properly designed intake and outflow eliminating environmental impact. Cross cooling system. The second is cross cooling system where circulating water in the closed circuit. The circulating water removes the heat from condenser and flow to the cooling tower. In the cooling tower, air flow, natural or force cool the water and water returns to the condenser. Power plant located away from the large source of water utilize this type. The large concrete hyperbolic tower that you see near thermal power plant are used for cooling the circulating water. Here advantage and disadvantage of closed cooling system. Now mixed cooling system. Cooling tower over in thermal plant. After air, where is most important requirement for life of this planet, with fresh water resource depleting and increasing population pressure, water source have become very precious. Primary priority of fresh water is human consumption and agriculture. Power plant requirements are only secondary. This necessity the need to for thermal power plant. that require less water. Cooling tower help by reusing the cooling water, making power plant economical and more environmentally friendly. Cooling tower can be two types. In natural draft cooling, tower with large hyperbolic tower which pull in air due to the stack effect, even though the capital costs are high, operating costs are less. This is because there is no fan create in the airflow. However, most commonly used mechanical and force cooling tower. A fan forces suck air through the cooling tower. When the water pours through a packed heat transfer media, operating costs are high for operating these, but they are simple and quick for construction. The fan are be induced fan or forced draught fan. Airflow can be parallel or cross flow of the water flow. Cooling tower can be two types. In natural draft cooling tower with large hyperbolic tower which pull in air due to the stack effect, even though the capital costs are high, operating costs are raised. This is because there is no fan to create their airflow. However, most commonly used for mechanical and force cooling tower, a fan forces suck air through the cooling tower, where the water pours through pack heat transfer media. Operating costs are high operating these, but they are simple and quick for construction. Here in last, the losses in cooling tower is given. Losses of water cooling tower is due to the three different reasons and has to be made up during the operation. The makeup percentage in modern tower is around 1%, like that. This is here we have completed our second unit revision lecture. Now next lecture we will discuss third unit of the energy engineering subject. Thank you.